Here we're trying to find the extrema, and we do have a variable over a variable, so we need to use the quotient rule in order to deal with this because it's a variable over a variable. So our top function will be 7x squared, and then our bottom function will be x squared minus 9. So our top function is just 14x, and then our bottom function's derivative is 2x. And with the quotient rule, B is for beginning, we start with the bottom and multiply by the derivative of the top. So when we plug into the quotient rule, that is us taking the derivative. So it's no longer going to be f, it's now going to be f prime of x is equal to x squared minus 9 is two terms, so we need parentheses there, and then 14x minus the other diagonal. So we have 7x squared times 2x over the bottom squared. So x squared minus 9 quantity squared. All right, so again, we do the little cross, we subtract them, and we put that over the bottom squared. Now, with the quotient rule, you need to remove parentheses or factor out a GCF. In this case, the easiest thing to do is just to remove the parentheses, and when we talk about this, it's just for the numerator. So you don't need to stress out about foiling out the denominator. So you are going to distribute the 14x to both the x squared and to the negative 9. And when you do that, you are going to get 14x to the third minus 126x minus, and then over here you have a 7 times 2, so that gives you a 14, and then the x squared, x to the first, those will add together to give you an x cubed. And that is all over x squared minus 9 quantity squared. Now, you also continue to focus on the numerator, you remove your parentheses, and you combine like terms. So in this case, I have a plus 14x cubed and a minus 14x cubed, so those cancel out. So you are left with, for your first derivative, negative 126x over x squared minus 9 quantity squared. Now, because this is now one fraction, once it is in the one fraction form, you then are going to set the numerator equal to 0, and that gives you where f prime is equal to 0. You then set the denominator equal to 0, and that gives you where f prime does not exist. And you're very, very cautious about this because this might correspond to vertical asymptotes. So you need to be careful about whatever numbers you get from this denominator equal to 0. All right, so I set the negative 126x equal to 0, and then divide by negative 126, and that gives us x is equal to 0 as a point to test to the left and to the right. Over here with this x squared minus 9 quantity squared, set that equal to 0, and then I take the square root of both sides, so I get x squared minus 9 is equal to 0. Now, we solved this equation before. We solved it over here when we were doing vertical asymptotes. And so there actually are vertical asymptotes at this plus or minus 3. And so we're very cautious there. We realize that's probably not going to generate for us a critical number, or not a critical number, but a relative min or a max, because there's actually a vertical asymptote there. But nevertheless, we continue onward and we draw our number line. So our number line is going to have negative 3, 0, and 3, and we're going to be plugging into the derivative. Now, when you look at the structure of the derivative, you're quite excited about this because the structure of the derivative has parentheses squared in the denominator. So it doesn't matter what the heck you plug in to that denominator, you are going to have a positive. So to ease your computations here, you really just want to plug into the numerator and keep in mind that the denominator is positive. All right, so to the left of negative 3, let's say I plug in negative 4. Okay, so I get negative 126 times negative 4 over this positive denominator. And the numerator here is going to be a negative times a negative, so that gives us a positive over a positive. All right, so then I test the next interval, negative 3 to 0. Maybe I plug in negative 2. So I get negative 126 times negative 2. Again, we see that that gives us a positive. Okay, now from 0 to 3, maybe I plug in 1. And so I will have negative 126 times 1 over a positive. So that gives us a negative over a positive. So we're looking at a negative. And then to the right of 3, maybe I plug in 5, and we get negative 126 times 5 over a positive. So that gives us a negative over a positive. So that tells us we have a negative. Now, even though it's very tempting to kind of want to put this together as one big interval, you cannot do that because there's that vertical asymptote at negative 3 and 3. So when you look at your answer choices, and we're working on number 6 here, right? So when you look at your answer choices, you want to have an answer choice that says that f is increasing on the interval negative infinity to negative 3 and negative 3 to 0. And then you want it to be decreasing from 0 to 3 and 3 to infinity. Okay? Now, in terms of the relative min and max, this is telling us that we increase, we continue to increase, then we decrease, and we continue to decrease. So there's only one extreme point, and that extreme point happens at 0. So to find the corresponding y value, we would plug into the function. So you do have a max, a relative max at 0. And so you go back to the original function, which was 7x squared over x squared minus 9, and you plug 0 into that original function to get 0. So what you would do on my math lab is when they say the relative extreme points are, you would, or the coordinates of the relative extrema, you would just type in 0, 0.